Welcome to today's Research Pays Off. I'm now going to hand it over to our speakers from NCAT, Drs. Adriana Vargas and Anthony Brenes, to discuss their work on using pavement preservation research data to demonstrate benefits and support decision making.
All right. Thank you, Lauren. Um, well, good morning, everybody. Thank you for joining today. What we're talking this morning about is some of the work that we have done through our pavement preservation group study, a pooled fund study that has been going on for a number of years now. So I'm going to start off by giving some background for those of you who are not familiar with this. And then I'll hand it over to Anthony, and he's going to talk more about some of the very interesting work that he did while he was working on his research for his PhD at Auburn. So, first of all, why pavement preservation? Why is this such an important topic? And it's just something that people know has benefits, and that goes as cost effectiveness and sustainability, condition improvement, of course, but often trying to quantify those benefits has been challenging, and that has maybe kept agencies from getting more into pavement preservation, just not having that knowledge of exactly what to expect from the different treatments. So that was one of the gaps that we were trying to fill with this study. Performance, we know, can be affected by many factors, and that could be traffic, could be climate. Most importantly, I think, pavement condition at the time of treatment. So all of those combined were variables that we were looking into, and that NCAT and of course, in partnership with MnROAD, has been studied for more than 13 years now. So we started this study in 2012, and it's still going strong. So our PG study, as we call it, is a long-term pool fund research effort. We've gone through phases 1 and 2, and that was heavily focused on gathering data, getting the analyses, uh, with the main objective of being able to quantify the life-extending benefits of the different treatments that are included in the study. We are now in phase 3, which still is looking at some of that data for the sections that are still in place. But now we're having a heavy focus on the implementation side of it. So for the different sponsors that saw some of the treatments that we had and they thought this is a good idea to try it in our own backyard, this is where we are right now, helping them being able to implement some of those findings. So for phases 1 and 2, we have test sections in 2 different states. That would be Alabama and Minnesota, and those were placed across 5 different roadways. That was a total of 145 test sections at a time. And that included some of the controls. Since then, there are sections in one of our locations that have gone out of the study because that was resurfaced. But most of the sections still remain in place and are still being monitored and analyzed to get that long-term data that's so valuable. So we have more than 13 years of performance data. Coming this summer will be our 14th year of the study. So to give you a good idea of that timeline, we go back to 2012 when we first started looking at all of these treatments. So the study started by placing test sections on a county road, low volume roadway in Alabama. So that would be a warmer climate. Um, we placed 25 different sections. Well, 2 of those were untreated controls, but we had 25 different test sections to look for all of the different performance metrics. So that's 2012. In 2015, NCAT started a partnership with MnROAD with the idea of, well, you're doing this work in the southern climate, warmer climate. What would be different if we did it in a colder climate? Are there going to be any differences in performance or not? So by doing that partnership, we were able to expand our experimental plan. We also looked into getting different settings for traffic. So we built test sections on a higher volume road in also still in Alabama in the warmer climate. But in 2016, we took all of those different treatments and just placed them in northern sections with a very different climate, um, but still looking at low traffic and high traffic conditions. Oops. Not sure why I'm going backwards. All right, here we go. Then 2019, we also completed a part of the experimental plan that had not been included until then, which was adding cold recycled treatments in the colder climate. So we had those as part of the 2015 round of construction back in Alabama. We hadn't gotten to those in the Minnesota sections yet. So those were completed in 2019. And now we really look at different treatments, different climates, different traffic conditions for all of them. And we finished our phase 2 at the end of 2023 and started phase 3 in 2024. And this is where we are right now. We have more than 20 different DOTs sponsoring the third phase. A lot of interest, some of the pilot projects being built already. But what this webinar focuses on today is more phases 1 and 2 and some of the projects that or the products that we have developed as part of that and how that can help agencies make better decisions when you take all of that valuable research data. Some of our test sections or what we have included as part of our treatments, it's a broad range of different options in there. So we can go all the way from something as simple as crack sealing. It's different surface treatments, and within that, there's different categories. So for example, we have chip seals, but within chip seals, we have variants of that. So it could be single layers, double, triple layers, combinations with chip seals and crack sealing, for example. Different things like using a fiber mat membrane for your chip seal. Put scrub seals in there in that category, but they're a little different. We have different types of microsurfacing, types of fog seals, thin overlays with different types of materials and mixed designs. And of course, I mentioned the cold recycling techniques. And some of our most successful treatments have been combinations of treatments, which could be like a cape seal, for example, a chip seal with a microsurfacing combination, and that within those different variants, like could be a scrub seal and a microsurfacing, or we have a chip seal and a thin overlay. So those types of combinations we have seen really good results from. We have a very extensive data collection plan. So throughout this many years, again, more than 13 years, we've been looking at things like cracking, roughness, rutting, texture. We look at the structural condition of the pavement, even though these are preservation treatments that are not meant to improve structural condition, but we think that if you take a pavement that's structurally sound and you treat it at the right time, that's going to stay structurally sound for longer. We look at friction because it's important. Some of these treatments are meant to improve your frictional characteristics and your safety overall. And things like permeability, for example, it's relevant for our OGFC thin overlay, so we look at that. We've done some moisture measurements on the Lee Road sections just to see, are we being effective just sealing that pavement surface and keeping the moisture out of the pavement structure. So even though we have all of these metrics and we do collect them and analyze them, typically when we present these findings, we focus on 3 performance indicators that are very common among the different state DOTs because it's the indicators from the MAP 21 criteria. So any state DOT person would know that you have to look at these metrics and be able to report them to the federal government. So cracking, rutting, and NRRA would be our main indicators. They have ranges for the good, fair, and poor categories, and they're easy to get that message across different audiences. We know that each DOT may have their own system, but this is the one that all of them have in common. So for performance, a very common question would be, well, what is the best treatment? But that is not really the question that we need to be asking. What we need to see is, well, how does each treatment perform under different conditions? And this is what helps us make better decisions as to what would be more appropriate for a specific scenario. So this is what we're trying to answer. We're not trying to say which is the better treatment, because everything always depends on what you have to work with. So the information that we have generated as part of this study has been very helpful to be able to answer those questions. One thing that I wanted to mention is how we look at performance for our sections. And yes, it may vary depending on your traffic and climate conditions. For example, we have seen that our warm climate locations primarily will have a dominance of cracking in the wheel path as their main deterioration mechanism. And for the colder climate sections, cracking is also an important, but it's a different type of cracking. It will be thermal cracking that determines the performance. And thermal cracking in turn affects roughness. So those are two different ways to look at performance, and it's important that we take that into account when we're working again with different conditions. What is the most appropriate way to look at the results? And here's an example. You can see there on the left side one of our southern sections, and that's a high traffic section. You can see that cracking there along the wheel path. For the northern section, it's going to be more transverse cracking due to the environmental effects. And it can be very severe, like I said, and be something that affects ride quality. Also, the condition of the pavement at the time of treatment is very, very important. And it's something that we see will influence the performance of any of the treatments. We can see here on the left side, that's the transition between two sections. So there's a chip seal and there's a cape seal. There was cracking on that pavement at the time of treatment, and that definitely will come back to the surface at some point. So getting a good documentation and a good characterization of the the condition of the pavement before treatment is very important to determine how effective it is. Same thing on the other picture. We see that we put that treatment on the main line, but the shoulder didn't get that treatment, and the transverse cracking eventually made its way through also. Now, for benefits, the performance side of it, and Anthony's going to talk a little bit more about other things, but for performance, we look a lot at life extension and condition improvement. So we take our untreated pavements and we compare the performance of that untreated pavement to the performance of the treated section, again, accounting for the existing condition. And we look at, well, how long would it take both of those to reach a threshold with the appropriate performance indicator. And the difference between those two will be what determines our benefit. So this is an example, a double layer chip seal this is Lee Road 159, which is the older sections or the oldest sections in the study. You can see three different curves in there, and with different colors. So the green is a pavement that gets treated when it's still in good condition. Then the yellow is it gets treated a little later when it's in fair condition, and the red is it's already poor, but we still put a treatment on it. There's definitely a difference in performance, and this is to be expected. You treat the pavement while it's in good condition, it's going to stay in good condition for a longer time, and the data have been helpful to support that. Now let's look at just the green, which is the good condition, your ideal window for pavement preservation. With the solid line is the treated pavement, and the dashed line is an untreated pavement. So they both start with the same level. In this case, is cracking that we're looking at. But the treated pavement is going to be a flatter curve for a longer time. It's going to deteriorate much slower than what you will see with an untreated pavement. So we look at, well, our treatment will be reaching that 20% threshold that puts it in the poor condition category at around year 13. If we had the same pavement and didn't do anything, we're going to get much faster to that point. So at around maybe year 4 or so. So what is the difference between those two is what's going to determine our life extending benefit, and that's how we've been treating those. If we look at condition improvement, we're just going the other direction, in the vertical direction, and it could be at any point in time. So it's important, for example, to note that here at year 5, there can be a very big difference between treated and untreated. You could be still in good condition or you could be in poor condition. So it's the importance of doing those pavement preservation actions when you still have a chance to extend that pavement life. So in this case, if you look at the 13 years and average those out, those arrows, you'll get an average crack reduction of 24%. We documented all of our findings in a report, and you can visit that. It's available. You can download it. That's on our NCAT website, and I'm just going to leave that there for a second. So that just documents the entire research effort, construction, data collection, notable findings. We also have a tool that we use, and this is mainly to be able to track that performance and to look at individual treatment sections and how they're doing, what has been the performance for them over time. And we have curves like this that will give us for example, cracking, and compare the treated to the untreated. And we can do that exercise that I just showed to how to look for those benefits. It'll give you the time to reach that poor condition threshold. But this is on a very specific level, treatment by treatment. Oops. So you can visit that also. That tool is available on our website. You can select the treatment, select your initial pavement condition, and play with it a little bit. But again, this is to visualize specifically our study sections, how they're doing. Now I want to hand it over to Anthony, who's done some work to take that into a level where it can be used more for decision making, and he's developed other tools that he's gonna talk about. So Anthony, with that, I'll stop sharing and you can take over.
Yeah, I'll go ahead and share. Thank you so much, Dr. Vargas. Are you all looking at my screen? Yeah. Yeah, so
Yes.
perfect. Yeah, as Dr. Vargas explained, like we have different pavement preservation treatment data available. So what we wanted to put together is go ahead and try to do a framework in order to quantify the benefits of the pavement preservation treatments. So when we place a pavement preservation treatment, we expect our pavement or performance to be better, but the question is, how can we quantify this based on the three E's? And I like to call it the three E's: the engineering, economic, and environmental, because when we place a treatment, we expect an improvement on not just ride quality, but in the overall pavement condition as well. This is gonna impact our users and have a better ride quality, and also simultaneously it's gonna help to reduce the emissions. But how can we calculate this and incorporate it into our decision-making process? What's the main objective of designing this framework? So with all the data available, we identify define six main steps in order to create the framework. First of all, we were working with a lot of payment preservation treatment types, as Dr. Vargas pointed out. So the first step was creating some families in order to have more condensed payment preservation treatments. After that, we were able to develop different payment preservation performance models based on the indicators Dr. Vargas was explaining. And then we wanted to study the economic assessment to see the trade-off between the agency cost and also the user benefits they get for improving right quality of the payment when treating them. And then this is going to be also reflected, and we study the environmental impact, specifically in tailpipe emissions that the payment preservation treatments were helping to users. And at the end, this is something that we're going to present here. We wanted to tie it all together and do an interactive tool to provide users with the ability of having their own inputs and being able to calculate the benefits payment preservation treatments can give to them based on their specific configurations or inputs they are experiencing. So as the first step, we talk about it. We have different payment preservation treatment test sections. So we can think as one of these boxes right here as an individual payment preservation treatment. And for representation, I'm just putting the two variables here for a two-dimension representation, but we can have different other variables as we included in the study. So we can think about these two variables, routing and NRRA. We were using a cluster analysis procedure that is an unsupervised modeling procedure that helps us to group payment preservation treatments with similar characteristics. So instead of talking of such a specific treatment, we can talk of a family of treatments in order to make a broader analysis of the problem instead of having like a specific treatment. So we can think, I like to think something like this is going to look like a broader perspective with similar treatments that form a family. So once we had the treatment families defined, as you can see, these were all the input parameters we use, and this result in 9 different clusters. And then the need to define some unit parameters for the cluster analysis procedures. But after defining all of this and having the resultant clusters or families of treatments, we were able to go to step 2, that was the performance modeling. That the main objective of this is to track the performance over time of the payment preservation treatments, but also to compare with the untreated section. So in this case, it's important to note that we follow a 2-step modeling procedures, and we can think about this red dotted line as the untreated and this one as the treatment, the light blue one. So when we treat a payment, we expect a immediate improvement in the condition, what we call the performance jump. And also we expect over time some changes in the slope of that deterioration. And the untreated section having higher slopes, which is going to mean that the payment is deteriorated faster over time. So in order to account for this, we follow, as I said, a 2-step modeling procedure using linear multi-effect linear models to account also for the time series nature of the data. And these models were normalized for traffic level, climate regions, and pretreatment conditions, as we all know that we have different test sections in different sites and conditions. So in order to be consistent, we normalize the models for all of this. And then it's important also to note that, well, for this case, we were using a IRI by 3 main reasons. As one of them, Dr. Vargas explains, we're working with 20 different agencies, so we wanted to be able to communicate the results effectively. So that was one of the main reasons. Then we also want to provide a consistent and systematic framework So IRI has been a really important input in determining and also calculating the user cost, specifically excessive fuel consumption that I'm going to explain later. So these all reasons were like main fundamentals in order to go with that indicator. So again, the IRM model is going to be main by two parts: the performance jump, the median benefit, and then the slope that is going to quantify that deterioration over time. So as Dr. Vargas explained, we can see something like this, in which this orange dotted line is going to represent the untreated section. We're going to have our immediate benefit, and then we're going to have also our treated section. And with this, we can calculate life extended benefits to a defined threshold. And this is a picture actually from the new dashboard we put together. I'm gonna show here in some minutes. So again, I think this was the case for a cave seal. So we can see like it took like 9 years for the cave seal after it was treated to that pretreatment condition to reach the threshold. And for the untreated section, it took around 1 year to reach that threshold. So the difference between them is going to be our life extended benefit from a deterministic way, that also this tool is going to account for some uncertainty in the input parameters that I'm going to explain also later. So once we define our first benefit that we have to keep in mind, that was the life extended benefit, then that is going to be related with performance. Then we wanted to study the economic side of the things. So when we look at an agency treating a payment in economic terms, we will think that yes, there are going to be costs associated with materials. There are going to be costs associated with lane closures, with operators, construction equipment, different costs that are gonna have to be covered by the agency. But how do we, during the life or the service life of that treatment, how can we justify that initial investment of the agency? And based on that, that's why we need to refer to road user costs that are gonna be the main characteristics that combine that condition or a specific condition to the payment to cost experienced by the users. In this case, this study focused on fuel consumption. So based on theory, this cost, or this vehicle operation cost, is one of the biggest costs in the whole matrix when analyzing road user costs. So at the end, we can think that if we have a payment in a bad condition, there is going to be more rolling resistance, it's going to be a rougher ride. So that's going to need the vehicle more fuel than if we create a payment, for example, then we create a better or smoother surface to drive in. So that is going to help us to reduce the fuel consumption. And also, if we think this is going to be just one vehicle, but when we have multiple vehicles on a road, and then day by day, that is going to add up together and create huge savings from the user cost perspective. So, well, this is how we can go from payment surface characteristics to instant fuel consumption. So as I already detailed a little bit, we will need different inputs, but the main process here that I wanted to point out is the use of payment vehicle interaction models. And I put a bridge here because I always think that I like to think that payment vehicle interaction models are like the bridge to go from payment surface characteristics. In this case, can be macro texture, IRI, deflections, typically depend on that. And then with that and all the traffic inputs, we can calculate the instant fuel consumption. It's important that here we're using a model called the HDM4. that it has their own calibrations for the specific traffic and vehicle parameters. So with that, we can calculate an instant fuel consumption for a specific vehicle, driving over the treatment, driving over a control, and it's also important in this kind of analysis to define a baseline that is usually something related to a brand new payment. So we are going to be able to compare treatment against the baseline and control against the baseline, and then compare within each other in order to have consistent and being comparing like apples to apples at the end. So with these differences, we can calculate the excess of fuel consumption, that with the price of the fuel, then we can get dollars. That is the cost, the user cost we're looking for. And if we think this in a life cycle process, we can think, and we can see here as this yellow arrow, yeah, we can think, yeah, at the point zero, the agency is going to have an initial investment. The treatment is going to cost something for the agency, but then overall, over the time also, when we start analyzing those differences of like what would happen if we didn't like treat our payment, is going to increase the damage is going to increase, the condition is going to be worse. That's going to be like helping us, or actually that is going to increase the user cost if we don't treat the payment. So in this case here, we're representing the savings actually that is going to be control versus treatment of how much user cost we are saving over time by treating our payment. So at the end, in a long short story, it's going to be the comparison between that initial investment to the reduction of the treatment versus control. So this is going to be our second indicator. We already covered the performance. So now this is going to be the economic side of the things. That is going to be the equivalent uniform annual cost. And in this case, we're going to have, again, an initial investment, and this is going to be positive for the difference between treatment and control. So a higher equivalent uniform annual cost benefit in this case is going to be the better. It's like the opposite, like from finance. And it's important also to define a functional unit on all these kind of studies. Something similar we wanted to do with the environmental side of the things. So in this case, we're comparing cradle to construction emissions, all the emissions from materials, transport, production, and construction that are gonna be related to all the construction process for the payment preservation treatment. And also, by the better condition we're providing to the payment, we expect also a reduction in the fuel consumption that we can translate. In this case, we use MOVE's procedures, that is the motor operation vehicle emission simulator, in order to quantify that payment surface characteristics improvements into CO2 equivalent emissions. So at the end, it's going to be that process of doing something similar to the economic side, in which we analyze and compare the initial investment in emissions to the reductions we are having for a better payment condition. So it's going to be something really similar right here. As we all know, like the emissions shouldn't have like a value or increasing value over time as money does. So this is going to be our third indicator, that is the equivalent uniform annual impact. That what it does is that it relates this initial investment in emissions, let's call it investment, that the agency is putting from material extraction, from material use from construction, and compared to the reduction of emissions due to a better condition in the payment surface. So again, This is going to be our third benefit. We got the life extension benefit from the performance. We got the equivalent uniform annual cost from the economic side. And then we have the equivalent uniform annual impact. And that is going to be divided by the analysis period of how long it took for the treatment to reach a specific characteristic or condition or threshold. So we're going to have those three main benefits on mind. As this point, we have been working everything in a deterministic way, but we need to remember that, well, we are working with three different indicators that they have traffic inputs, they have materials uncertainty, they have uncertainty in the construction practices. For example, how do we quantify the ADT? All of that is bringing different uncertainty into the process. So how can we account and incorporate that uncertainty into our decision-making process? So in order to do that, we follow and we develop a Monte Carlo simulation approach for this case, in which, based on theory, for each of the inputs we were having, we develop their own specific distribution, and we can think this is going to be our traffic ADT. We can think this one as our class growth, vehicle speed, different. So instead of talking about just a deterministic benefit, it could be life extended benefit, it could be equivalent uniform annual cost. We're going to think about a distribution of that benefit. So another point that we wanted to develop here is that, yeah, we developed the framework, but how can we bring to the agencies or bring to the user something useful where they can, like, and tangible at the end, where they can, like, go ahead and do their calculations. So for this process, we developed an interactive tool, an interactive dashboard, in which we are putting and documenting all this framework in a systematic way and in a way that the user can go and modify their inputs in case they need or they want, and to quantify their own payment preservation benefits for their specific conditions. So this is how the interactive tool looks. It's divided into different main tabs that I'm gonna show you in a couple seconds. So here's gonna be just a link for the tool, and I'm gonna leave this link also in the chat. But we're gonna move from here to the tool right here. So it's gonna look like this. This is gonna be the main interface. So here you have a small help button where you can see how it mainly works. But at the end, the main objective of this tool is to quantify those benefits. So you can see here, you can input your pretreatment condition. For example, let's say you want or you have a pretreatment condition of 95 inches per mile, then you want to treat your road with a capsule. These are the families we created from the cluster analysis. You can open the more info to see which are the treatments that are included in those families, and then you select the traffic level. And we are defining this traffic level more like a payment structure condition, I would say, like or subdividing this more like into a payment structure condition, like for a high traffic road and for a low traffic road, more related to the payment condition than the ADT or traffic cone itself. It's important also, well, we put here some read terms and conditions before you're able to calculate. You can just go and read through them. It's going to tell you the condition of the test sections, and the test sections we use for this analysis right here, more about the study. And also we have some documentation here that is gonna be the whole documentation of how this tool was put together and how all the calculations were done. So this is going to tell you more about if you want to go more in depth about this whole process. But going back to the tool, so this gonna be the main tab right here. Then you can go ahead, generate your predictions. You're gonna see here, as we say, the treatment, the untreated section right here in light blue. Then you're gonna be able to see from a deterministic way what is gonna be the improvement, the condition for that point. You can export this to CSV files. Then you, with this other tab, you can calculate the life extension, for example, and move your threshold to see what is going to be the time that it takes for a specific treatment to reach this condition, and as well for the untreated section. And again, this is going to be from a deterministic point. And then you can also go ahead and calculate the economic impact to study that trade-off between the initial investment and also the user cost reduction using the payment vehicle interaction models. So here we're like suggesting some costs based on literature reviews. We took a database from the National Center for Payment Preservation. It's an updated cost, but of course you can change it like based on your agency cost per lane mile for a specific treatment. As well, you can change the discount rate or the vehicle class mix, your ADT, and as well as your operation conditions. So at the end, for you can calculate what is going to be the fuel consumption impact for that analysis period for a car, for a medium truck, and for an articulated truck. And combine all of them together in order to get a cash flow that you all can see here. So this is going to be the initial investment, that is the cost of the agency of treating a lane mile with that specific payment with that specific payment preservation treatment, in this case capsule. And then in green is going to be the savings the users are getting in terms of fuel consumption. So we can see also the payback period, how much time is going to take to the agency to get that money back that they put into preservation just based on user cost. Something similar was done from the environmental side. That, well, we get the cradle to construction emissions. Of course, again, you can change it to the number you are experiencing, or if you are measuring something, we are giving basics or like a start point number based on theory, because at the time of this study, we didn't have like any measurements. So we did an extensive literature review in order to get some emissions for the different treatments, and as well as energy consumption. So you can see some examples here. And again, all is well documented in the document at the information tab. So you can calculate the cradle to construction emissions, and you can calculate that reduction from the use phase. And these charts show you for the analysis period that you can change here as well. You can change your ADT from a deterministic way to see what is going to be that equivalent uniform annual impact benefit in terms of emissions. And this final tab, it's related to a certain analysis. Now we have been doing everything deterministic. How can we switch and give some uncertainty to our input values, and then being able to calculate benefits, but in terms of distributions, not just a single value. So based on theory and as documented, we did an extensive literature review in order to see what are the most common these distributions in order to calculate those benefits on a probabilistic way. So you come here, you change your iterations. It's recommended to do it on batches because it takes time. It has to go like through all the HDM4 model that is going to be the PBI and calculate again. But what are you going to get at the end is something like this of these three benefits. Instead of talking of a single value, you're going to get a distribution. So you're going to be your percentile 50 for a 50 percentile is going to be around $8,530 of the annualized benefit we are getting. So the question is, what can you do with this? How can you, yes, we calculate the benefits, but how can we like incorporate these benefits into our decision process? That is the question at the end. So this is going to be just a tool to calculate those benefits, but how can we incorporate those benefits to our decision making is the question. So before going to that, it's important here to say that, well, you can download your iterations right here in a CSV file, and well, it's gonna open right here. So you're gonna see one of, I think I run here 400 iterations last time. Yeah, last time. So you're gonna see for those 400 iterations, you're gonna see a benefit here and cost benefit, environmental benefit, and life extension for that capsule with those road conditions, and the specific values for those iterations. So, well, with those values, we can go back to the presentation. I'm gonna share the presentation again. So what can we do with those values? How can we incorporate those values into our decision process? So this was an example for one of the roads we were doing. That is the or one of the roads we have in our study. That was the US 169 in MnROAD. So we were grabbing all the inputs and characteristics for that road and running this same analysis using the tool. So in this case, all the iterations here, we run like around 2000. We can see something like this. If we put in a three-dimensional way, we can see something like this. So what do we want at the end? We want the treatment with the higher benefit in terms of cost, the higher treatment with the highest benefits in terms of environmental components, and the higher treatment that is bringing us the highest life extension benefits. So it should be something around this point right here at the top corner. So as we can see, this is like a cloud of points. So we have been developing, and we develop some metrics in order to take the decisions based on that is, which is going to be the treatment that at the end is giving us our greater benefit. And probably we cannot look the difference between here, that in here is the orange, the micro, and the capsule in blue. But if we look these kind of plots, it's going to give us a better representation. And I like to think that these are like elevation curves. So the closest you are to the circle, the most of the data is gonna be concentrated in this area. So our equivalent uniform cost benefit for the capsule is gonna be something around here, and for the micro around here. So we're gonna see that in this case, capsule in average is being better than micro if we analyze these two dimensions right here. But then if we go right here, we can see that this is going to be a life extension benefit. Yeah, in the y axis, and in the x axis we have the environmental benefit. We can see some overlap between them. So how can we take the decision based on all these indicators and this data? So we develop like some metrics that is going to help us to say, well, this is going to be our winner or our best treatment. So just to bring an example, this is the dominance probability. So it's our objective function is to determine which is going to be the treatment that brings us the highest benefits in the three components. So it's accounting for that and measuring how many times capsule, for example, beats micro surfacing in the three indicators right here. For this case was around 95%. So this brings us like a systematic way in which we can use and calculate the benefits that these pavement preservation treatments brings, and also to compare between them. It's important also to note that this is done after the initial selection. This should be done after the initial selection, because typically you select a pavement preservation treatment initially based on the distresses you want to address. And after that, you can run this type of analysis in order to see which is going to be your most feasible alternative from the treatments that you already select. So in conclusion, the purpose of this study was to integrate from performance all over to economic and environmental components, and to determine what are going to be the benefits of those pavement preservation treatments. The approach we follow was to define a systematic framework that can connect all these three main areas: performance, economic, and environmental. And as you saw from the tool, it has different capabilities. You can see IRR progression curves, you can calculate your life extension as well as your benefits, and also you can incorporate uncertainty into your analysis. And then what is gonna this is gonna help to support your decisions after you select a couple or three or more treatments that are gonna be feasible for the distresses you are aiming to tackle. So thank you so much for the time and for connecting today to a webinar, and we're open to any questions you may have.
Great, thank you so much. We have had a few questions that Adriana has answered in the chat. So I might just open it up to anybody else who has any questions, any further questions they'd like to ask, and you can ask it unmuted if you'd like. All right, I'm not hearing anything, but I will just kind of breeze through some of the question and answer here. Glenn asked about implementation of pavement preservation at state agencies and how that could be increased. And Adriana just said that, you know, long-term studies like this help improve the confidence for the state agencies on what to do and on the information, because it's so long-term, right? And so some of those risks can be mitigated that way. And then someone, let's see, Regu asked about the typical ESOL ranges for high and low traffic levels. Adriana said that they have AADT data for low traffic locations that are around 500 VPD, while the high traffic locations are in the 18 to 20,000 VPD range. And then Regu also asked about the percentage on trucks, and Adriana said that it varies by location. The low traffic sections have a high percentage of trucks. And maybe I'll just read this whole thing. Lee Road 159, which is a dead-end road leading into a quarry and asphalt plant, has 60% truck traffic. The inbound lane empty trucks has accumulated about 150,000 ESOLs over the last 13 years, and the outbound lane loaded trucks has accumulated more than 1 million ESOLs over the same period. And then someone, Hafiz, has asked if the recording is available, and we will have it available on our YouTube channel by the end of the week. And that's under the NRRA YouTube channel. And the links, Hafiz, since you're part of DOT, you should be able to see those links further up in the chat. Any other questions? We have a couple minutes left.
We left our contact info if anybody would like to ask something later. We gave you some of those links to access the tools. They're available to use if anybody wants to just play with them and let us know what they think. Any feedback is welcome.
Yes, and oops, I have the wrong person here. I did, Adriana, I did type your email address and put it in the chat, and Anthony, I missed adding yours so that it's a little easier for people to grab. Maybe you want to just add it for us.
Yeah, I'm just gonna right away, so they can have my contact information too. Thank you.
Sure. All right. Well, if we don't have any other questions, I want to thank you all for joining us, and thank you to Adriana and Anthony for presenting today. Sounds very interesting, and like you've got so much content available. So Anthony just added his email into the chat there too. So if you'd like his email, you can grab that before we close out. And hopefully we'll have an announcement for our next session next month pretty soon. In the meantime, stay safe on the roads wherever you are, and hope the weather is cooperating for you as well. See you soon. Thanks.
Thank you.
Thank you.